and launching an online learning management system and everything in between. I started out as a guitar maker and I'm still fundamentally a guitar maker, but there's all kinds of other things that I help with around here. And I came to work at Taylor Guitars in April of 1992 at a time when the whole company was 35 people and we were making 11 guitars a day in one little shop in Santee about 5 miles that way. And I mean, look at where we are now worldwide. We employ 800 people. We estimate we'll make probably 120,000 guitars this year. Is that the right number? Yeah, something like that. Well, currently 500 guitars a day between here and Tecate, and I guess there's about 200 working days in a year or something like that. So you can do the math. I'm not good at math.
What does Tecate make?
Tecate is a little town in Mexico, Baja California.
What kind of guitars do they make?
Anything that's 200 series or below that in our model line. So the Baby Taylors and GS Minis, the 100 series and 200 series. I will assure you that they make guitars exactly the same way in Tecate that we do here in El Cajon, just making different models. So when we're in the factory and you see CNC machines and you see robots and UV finish and lasers, and you see people with a high level of guitar making skill to complement the technology, it's the same in Tecate. It's just different guitars and different people and different location. Actually, they make 340 guitars a day. In Tecate, we make about 162 guitars a day here in El Cajon. So that's been an interesting ride from 11 guitars a day to over 500. And worldwide, we also have a business and sales and customer service center in Amsterdam to take care of our European market. And we have an ebony mill, or we're part owners in an ebony mill in Cameroon, Africa. So there's actually 4 physical locations of Taylor Guitars all around the world. And when I started, everything was here in El Cajon, and pretty much all of our sales were in North America. We were just starting to break into some of the overseas markets, so it's been a pretty interesting growth. Before I go any further with anything, there's a few ground rules to cover before we go out into the factory. First of all, already had this question, is it okay to shoot video and take pictures? Absolutely. Please, as long as you're not interfering with somebody's work while you're doing that, then we're fine with you taking away whatever, mementos of your trip that you would like to. The other things have to do with safety. The number one, and the reason I like to give this out at the beginning is, other than what you brought with you, this is the only thing that you're allowed to put your hands on for the next hour and a half. So that means please don't pick up any, well, other than here in the visitor center, don't pick up any guitars, pieces of wood, scrap wood, tools, people, So if this is yours to keep, and besides being like a physical reminder about the no-touch rule, then also there's a few things I'm going to point to in this as we go along the way, because you can learn something about guitar making just from this little piece of wood right here. So that's safety rule number 1, no touch. And number 2 is staying in designated walkways, and the factory floors are painted with yellow lines. So stay between the yellow lines, don't step over a yellow line, because if you do, you're in somebody's work area, and that's possibly dangerous, and mainly it interferes with them trying to get guitars made. So that's number 2. Then the other things are just a couple of reminders. Please stay hydrated. Grab a water bottle. Bring it with you, and there are also water fountains along the way. If you see one and you're thirsty, don't hesitate. I have yet to have anybody pass out on my tours from dehydration. I don't want today to be the day, right? It is a little hot and dry. And but I mean, on that note, if you do, for any reason, have any kind of issues along the way, just sit down right where you are, and we'll get you help if you need it. And again, hasn't happened on my tours. I have a really, really high survival rate on my tours, I'll assure you also. Don't get scared, but our insurance requires that all this be covered up front. So unless you wear prescription glasses also, please keep on your safety glasses throughout the whole tour. And we'll be walking outside and into the back of this building, then we'll work our way back to the front. That encompasses our milling, wood processing, also finish and final assembly. So there's like a big gap as far as operations, but the processes of actually fabricating a neck and a body, they happen in the next building. So we'll cross the parking lot at that point and we'll go and see the neck and body departments. Part of the body department, the bracing and the side bending departments, are up a flight of stairs. Does that present a problem to anybody to climb some stairs? Okay, just making sure. And with that, I think that's all for the guidelines, the safety guidelines. Everybody good? Sound is working well for everybody? A-okay on the sound? Okay, so let's go ahead and get started. We'll head out the front door. Cut down the length of a log in parallel boards. That's normal wood processing. It doesn't work for guitar tops. The logs are cross-cut, and the stumps that they chop off are as tall as a guitar top is long. And then those stumps are split into wedges, and then the wedges are sawn very carefully so that the saw cut is as close as possible 90 degrees to the growth rings of the tree. So now when you look in at your piece of wood, if you this way find the orientation of the grain lines and then rotate it exactly 90 degrees, and you should see that those are as close to perfectly vertical as possible. Again, that's called radial sawing. Quarter sawing the log kind of gets you close. For those of you that are lumber aficionados, kind of gets you close, but not really the same as true radial sawing, which is what they do. And then as they're sawing on the face of a split wedge, they have to constantly rotate it just a little bit to keep that saw blade going perfectly 90 degrees to the grain. And the purpose of the splitting in the first place was to make sure that also the fibers of wood are parallel in this direction. If you split the wood, it shears between the fibers rather than a cut that might go slightly, across the fibers.
Is that how you get both halves?
You are way ahead of me. So now if you look at this piece, every 2 consecutive cuts from that spruce wedge are kept together. When we get them, we mill a very straight edge between the 2 halves. We fold them open like a book, and we glue them right down the center. So there's a glue joint right down the middle of this because it came from a guitar top. Okay. Hopefully you don't see an actual glue line, but you can see where the grain pattern converges in the middle of that piece. And that's called book matching. Spruce tops always book matched. Guitar backs always book matched, although sometimes there's a third piece in the shape of a wedge between the 2 halves of the back. The 2 sides of the guitar are book matched too. But when you're talking about sides and backs, then you're talking about hardwoods, and that's different. And we'll get this stuff oftentimes in more of a rough lumber form. I think this is koa right here, if I'm not mistaken. It's going to be guitar sides. So these boards, they're cut as close to the way the spruce is as possible, but they don't literally split and saw. They just try to keep the saw blade going more or less perpendicular to the growth rings of the tree. Then when we get this lumber, after a period of air drying out here in the sheds, we bring it into our mill and we stand it up on edge and we take off slices that are under 1/4 of an inch thick. And then again, every 2 consecutive slices will be the one side and the other side of the same guitar. So you can imagine we have to keep everything together when we saw it so we don't lose track of the matched sets. If it were maybe 3 to 5 inches wider than this, we'd do the exact same thing and we'd have the 2 halves of the back of a guitar. So they could be different hardwoods, koa, mahogany. This particular mahogany now is cut for necks. So when you look at the cross section and it's square, in this case milled down to a 3.5 inch smooth square surfaces, that's going to be made into necks. Every length of this material makes 3 guitar necks, and I'll show you how we do that when we get inside. Here's some smaller koa. I guess we're going to use this for ukuleles or something.
Oh, you make ukuleles too?
We do make some ukuleles on occasion. There's nothing in our price list at the moment, but that could come back.
So you're going to challenge Kamaka and Sunny B, huh?
Yeah, we could challenge anybody. But no, there's some great ukuleles coming from Hawaii, and I think that's a challenge for us. It's not about just making as good an instrument, but it's carving out a part of the market.
Yeah.
And when there's already, established names in there, that's a challenge for sure. I mean, it took Taylor Guitars 40 years to carve out the share of the acoustic guitar market. that we have. Even though our guitars were better than everybody else's 30 years ago, it still took us another 30 years to, but that's another story. So lumber out here is in the stage of air drying, and that's the first step in controlling the moisture content. It really begins as soon as the tree is cut down in the forest. Wood has been resawn, then we build up sticker stacks. A pallet of wood. If you all will watch from where you are right there, these are from mahogany side. They're roughed on to thickness, and they're stacked up with spacers in between so that air gets to all the surfaces of every piece of wood that's in that stack. And then we wrap it up with metal bands, and we move it into a kiln we have in the military. The environment in the kiln is very hot and dry, like 100 degrees Fahrenheit. And even hotter and drier than outside. In the kiln, over a period of maybe 1 or 2 weeks, this pallet of mahogany is filled with 50 gallons of water. As soon as there's no more water to suck out of that wood, then we bring it out of the kiln and we reactivate it. It's not going to stay bone dry once you bring it back out into normal humidity. But the kiln drying has the same effect as the first time you wash and then hot dry a brand new pair of jeans. Right? Then a hot plank fiber behaves exactly the same way. That's going to be 99% of the strength. You reach the minimum dimension of that wood by over drying it to almost 0% moisture content. And reactivate it. So it swells back up a little bit when we bring it back into a normally humidified climate, but re-shrinking and then readjusting to a stable humidity level makes the material itself stable from that point on in the process. Okay, let's go this way. I'm going to show you the kiln that's 3/16 of an inch thick or less, maybe down to 1/10 of an inch by the time it's actually guitar back, and it's 20 inches wide. If you have just 15 percentage points of humidity difference, this can grow by a 1/16 of an inch or shrink by a 1/16 of an inch. Once you've got braces glued on the underside or the back or the top, and you get any width change in the top, the whole thing turns itself inside out. So we can't have that going on. With next, we make sure that the humidity is stable, but the temperature may go up or down. Like out in that area, we have swamp coolers. The best they can do is bring whatever the outside temperature is down about 10 degrees. But we just keep introducing enough vapor. So even if the poor guys out there are working in 90 degrees Fahrenheit, which sometimes they are in the summer, at the height of summer, the humidity at least is still in our safe range, which is like around 50, say between 40 and 50. Now, guitar body parts, though, we're much more careful than that. So every place these parts go from here, the bracing department, side bending department, body assembly, bind and sand, finish, final assembly, all have the exact same climate. So we're not chasing dimensional change on the parts at that point. So we talked about center joining, everything, all the backs, all the tops, have a glue joint down the middle. And in some cases, that glue joint is decorated. Like this will be one of our 800 series backs. And we have a thin strip of maple glued between the two halves of the rosewood. It's not so pretty on the surface right now because we didn't do any surfacing yet. We just made a tight joint between the two halves and glued them together using this clamping press. And then once that glue has set, I think they do this on second shift that comes in at 3:30. They'll take these and they'll run them through a surface sander right out. They don't spend much time, just a few minutes to go through the surface sander, get nice and smooth on the inside and the outside. And they come right back in here in this room for lasering. Edge of the top and makes it the shape of a guitar top, and it also cuts this hole in the middle of the sound hole, and it cuts a place where we know the bridge is going to glue on later. If you look at that top that's handing around, you can see the outline of our Taylor bridge in the right position on the top. We don't actually use those laser marks to line up where we glue the bridge. we use those laser marks to mask off that part at the top before we finish the guitar. So that after finishing, we can pull that mask off and we have a bare wood footprint in the right place, the right shape for gluing on through. And in this case, once this part was cut out, we put them back on the laser to make our logo and the decoration on the surface of it. So lasers can either cut all the way through material if it's not too thick, or they can just make marks on the surface that help us line things up for different processes. Is the excess ever recycled? That's a really good question. If we get, for example, spruce tops that we can actually make a top out of, we sand them down thinner and we use them for some of the other internal structure of the guitar that needs to be spruce. These parts that come off the laser, there's usually not much of anything we can do with those, so they get chopped up in a wood chopper out back, and I think Caltrans gets that. I think they can to take away our scrap and they use it for landscaping. Bigger scrap that actually could be used for project wood is available to employees only. And also we donate a lot of that to the San Diego Woodworkers Association that makes toys for orphans in Tijuana. But we always try to get something out of it before we give up and throw it away. It's too valuable otherwise. But let me talk about this again, because the top, once we've lasered it back, it's ready to go to the body department and be braced. But on the top, there's another step. So this hole in the middle just gives us a way to locate the whole top on the CNC machine that was in the corner of the middle area back there. And there's a special cutter then that lowers down on the head of that machine, cuts all the way through the top to make the sound hole. So this edge is not lasered. You don't see the characteristic scorching. It's very clean, and actually on the side of that cut that's left in the guitar top, it's very square, right? So the bevel on the knife is to the inside. So this may not be perfectly square, but the hole that it left was perfectly square. Laser doesn't really do that very well. And then the same tool that cut out the sound hole cut the channels for the rosette. And I'm going to double back this way and show you. Well, no, not yet, because this hasn't been sanded. At this point, we've left some extra thickness in the spruce because we know we're going to have to do another sand out after the rosette is inlaid. So the tool that made the sound hole also cut the channels around it for the rosette. And we have every pattern of tool for every pattern of rosette that we do. Some of them have 3 rings and the dimensions, circumferences, or radii are different. So that's done with a tool that has really, really sharp cutters. And the sharp cutters have to be maintained. While we're here, I'll show you some other things that lasers can do. These are the wood vine inlays that we put in our Koa series fretboards. So if I pulled this tape off the back, all those little vine shapes would fall out of there. You can hand that around.
And what's that cut with?
That's with the laser.
Okay.
And peghead logos. We have celluloid plastic with an ivory grain to it. No elephants ever harmed to make any Taylor guitars, I can assure you. But this piece of Ivoroid was lasered out to make Taylor logos to inlay in peg heads. And typically we mill those openings out on a different machine. In this case, we just lasered one as a sample. So lasers are really helpful for intricate kinds of cutting like that. Okay, so now we'll continue on to the rosette room, because once those channels are machined in there, from that point it's all handwork. Touch, but this, they're putting together a Jason Mraz signature model rosette. All the pieces of wood for that rosette are lasered out individually, and then they all fit like a jigsaw puzzle into the channel that was cut out in the top. And a more typical kind of rosette would be something like this, where we have strips of laminated fiber, like black, white, black patterns, bordering pieces of abalone. And I'll just pass a few of these around. We're using solid abalone shell. It's milled by our suppliers, so we don't have to cut this stuff in-house. You know, pearl and abalone make a nasty, toxic dust when you mill them. So we have our suppliers that have the right equipment to do that for us. But they're working to our specifications as far as the radius of the arc and the thickness, and you know, different models. Those dimensions are slightly different.
Where did they make that?
We have a couple of suppliers. One of them is Tom Ellis, Another one's called Pearl Works.
Are
I
they in the
believe.
US?
I want to say yes, but don't quote me on that. Don't quote me on that. Yes, sir.
Abalone is a good sushi also.
Yeah.
But when you take a look at the shell itself, it's always very curved.
Yeah.
How do they get these straight pieces? with the
Usually
curve?
the most you can get out of abalone shell is pieces that are about 1 inch square and flat. Maybe 60 to 70 thousandths of an inch thick. So you're right, there's no broad pieces. But I'm glad you mentioned that because there's a technology now which is called laminated abalone, where basically they take flake and they reconstitute it into wide pieces or into long strips, and that's great for us when we're doing abalone trim around the edge of a guitar, because that material just bends like a piece of binding or purfling, and you just string it around the edge of the guitar and glue it down, and once it's all cleaned up, it looks just like solid abalone, but it's not really. In the rosette, these are all just small pieces of solid abalone that butt together end to end to form a continuous ring by the time they're all put together. And we're doing some things with synthetic pearl and stuff like that too on some models. So, yeah.
I was at a road show a couple of years ago, and they said that a couple of guitars they didn't have because they were held up at the border.
Yeah.
Because they said the abalone was endangered or something like that.
Right.
Is that still a
we
problem?
have to have paperwork for everything.
Yeah.
So it's almost like everything nowadays has a legal source and a black market source, and you have to be sure you're getting things from the legal source, and that means having paperwork all the way down to the person who pulled that shell out of the ocean or cut that tree down in the forest. And so we always make sure that we have all that in order. And in fact, that's a reason why our supply chain in many cases goes all the way back to the forest. I think in the case of the abalone, since we're not the buyer of the raw material, that's up to our suppliers to make sure they've documented their source for it. But with mahogany, with ebony, we actually manage the supply from the time the trees are cut down in the forest all the way to us. So it's all accounted for, certified.
Is the koa Hawaiian or Brazilian?
It's Hawaiian koa. True koa only comes from Hawaii. There's another material we build some guitars out of. It's blackwood, which is an acacia tree, which is virtually a cousin of koa, but because it comes from a different kind of a different part of the world, technically it can't be called koa. But when you make a guitar out of it, it looks like an unfigured koa. The true koa that we use, like this T5 top here, the second one from the right next to the skeleton guitar, almost all the time when we use koa on a guitar, it's highly figured like that. The blackwood that we use tends to be a little plainer, but it's still got that kind of golden brown color. And it's the same genus of tree, which is acacia. Any other questions in this room?
Is that walnut or what?
Yep, the one next to the koa top is a walnut top. The one next to that is sinker redwood. So that's a redwood tree that was shipped downstream from the high Sierras, but for whatever reason became waterlogged and sank down to the bottom of a river or a lake. And the California law is that you can't dive for those logs and pull them up, but if they come up naturally, then they're kind of fair game. I guess you have to own the land. So once in a while we get some sinker redwood, and what happens is all the minerals in the bottom of the river or the lake leach into the grain of the wood and turn it dark and stripey like that.
Now where's Cocobolo?
Cocobolo is sometimes called Mexican rosewood, so it comes from southern Mexico and down into Central America.
Okay, so the ebony is the only one from Africa?
Ebony is not the only one from Africa. We also use ovenkal, and we use sapele. But and there are other kinds of ebony that don't come from Africa that we use as well. There's a Macassar ebony that we use, not normally for fretboards or bridges. All of our fretboards and bridges are, traditional name for it is Gaboon ebony, so it's from Western Africa. In fact, the reason we got involved in the ebony mill in Cameroon is because the last country that legally allows export of ebony in the whole world is Cameroon. And so we wanted to get in on the ground floor of that in order to protect the supply. Not so much to corner the market, but to open up the market, because tradition is that ebony that's not jet black was regarded as useless and not worth anything on the market, and so Cameroonians wouldn't even bother to, you have to cut the tree down to see what the wood looks like. But then if it wasn't all jet black, they'd just leave 9 out of 10 logs sitting on the forest floor. And so Bob Taylor and his partner Bedinter in Spain intervened and actually bought that mill, got a license to cut so many trees per year. And we are doing our best to force the market to accept that ebony is not jet black. If ebony has to be jet black, we're going to have no ebony soon. So get used to seeing, you know, the brown marbling and that kind of stuff in the ebony. But look at the other side. Now we've got 10 times as much ebony available because we don't restrict it to just the jet black stuff. And actually, Taylor started doing this decades ago. When I first came to work here, many of our fretboards, most of our fretboards were not jet black. And we used them all. We graded them, you know, if they had a lot of brown in them, they were baby Taylors, and if they were jet black, they were presentation series. Everything got, it's just a matter of getting the rest of the guitar world to realize that that's where we are. Okay, you want to keep going?
So do other companies buy the ebony from you?
Yes, if they want ebony, they're going to buy it from us. You know, so once a body and a neck are made, then they go through a finished process. And the end of the finished process is buffing the final surface to a gloss. So before this, basically to get the wood finished, we start with paste fill, a clear, thick gel worked into the grain of the wood to level it. Then we spray a first coat and a final coat. There's only ever 2 coats of finish on a clear finished Taylor guitar. There's only ever 2 coats. That top coat goes through a very careful hand sanding down to a 1000 grit sandpaper. That's called rub out. So what that does is make the surface very level with a microscopic scratch side. It's not going to look shiny when you've done the rub out, but it's prepared properly so that when the robot gets a hold of it and goes through the motions of working the body of the guitar against the buffing wheel, those surface scratches kind of heat up and blend and meld together and leave a mirror shine. We've programmed the robots to get us about 90% of the way there. And we purposely didn't try to teach them to do the last 10% because they just don't have any understanding of finish. That's the limitation of machines. At some point in the buffing, let's say you totally started by hand and buffed the guitar completely from the rub out to the final gloss. For 5 to 10 minutes, you'd just be doing this. You could almost do it with your eyes closed. You just have to go through a pattern and a certain number of repetitions on every part of the surface. That part, like I say, you could literally do with your eyes closed. But once you get that far, now you've got to stop and you've got to look and you've got to see which spots are a little duller than other spots. Give them just a little attention, and you've got to work it right up to that line where it's shiny all over, but if you went any further, you'd rub through the finish to the wood underneath. And that's the kind of decision, you know, processing that the machines aren't capable of doing. So we get them to do the busy work, and then we hand them off to a person who will do that, you know, the last 2 minutes of touch-up by hand.
Are those for renew or revive, whatever? Those are...
Oh, you're talking about the repair package that you get?
Yeah.
Yeah, if there's any touch-up needed, they may spot spray. We're talking about a repair process. If you bring a guitar back that the finish is looking kind of worn, we may fill dings, we may spot some places on it and then do a light rub out and then buff it up to a gloss. They're probably going to do all of that by hand up in the repair department, because if you've got a guitar that already was completely buffed at some point in the past, you don't want to run it through the whole program all over again. That would be too much. You could probably run through it. Yes, sir.
There is a competitor that boasts about their finish that that they're the only ones allowed to be able to use that type of finish that it allows the guitar to have a more whatever sound. And I don't want to mention, and I'm not going to mention names, but is there your particular coating that you use or surface,
Right.
The lacquer that you use?
Okay, what I'll say is that finish is important to the tone, but mainly because it can only have a detrimental effect. It can only restrict the vibration in wood. So really the key is using material that is flexible, that doesn't dry really hard and brittle, which already rules out lacquer. Okay, I've been here 22 years. Lacquer was long gone before I ever started working here. We've gone through a number of different materials. Right now it's a polyester. It's a UV pure polyester. But the other consideration is keep the finish absolutely as thin as you possibly can. And so our robotic spray system, that ties in very nicely to where we're going right here. Our robotic and here the robot is spraying a maple guitar. That's a water clear. We didn't stain or otherwise color the wood, so the maple and the spruce are both very white. It went through 2 applications of a clear case filler, which also didn't add any color to the wood, but leveled the surface. Then we did a base coat earlier in the day. We fired that off in a UV oven, which is on the other side of the robotic spray cell, and we hand sanded that. Now when we spray the first coat, the fluid quantity is set specifically for a first coat. It's coming from the paint cabinet outside here. The flow rate of the finish is just enough so that in the time that it spends under the spray head, it gets a thick enough coat for a first coat. The first coat has to be sanded fairly aggressively to level it, so we know we're going to take off more material when we're sanding the first coat, so we built it up a little thicker when we sprayed it. The UV cure makes it get hard in a matter of seconds, really. It's an 8-second cycle in the UV oven, but we have to do that 3 times altogether with a little bit of cool down. And speaking of which, I got some finishers here that are coming back from their break, so we'll want to let them get to work. And you're going to notice that most of the people are not in the spray room. Most of the people are in the sand out room, because what makes the difference is the surface preparation every step along the way, and that's not mechanical. That's done by people that know how to work with the right abrasives and the right processes each step. So the first coat is sprayed kind of heavy, but then a lot of it gets sanded away after it's cured to make it level and ready for the final coat. The final coat goes on a little thinner because the rub out is lighter and with a finer abrasive, and then by the end of the buffing process, we land at 6 mils of finish thickness at the end of the process, 0.006 of an inch on most guitars. Now our new master builder, I say new, he's been here probably about 3 or 4 years now, Andy Powers. He challenged us to figure out how to get that down to half, and we actually achieved 3.5 mils. And that's not the technology. I mean, it was a matter of a few lines of program code to have the robot spray less finish, but where it really, the critical operation is what these people are doing right here in the sand out. When you have less of a skin, a finish on there, you have a much more skill required to get it level without going through it. So the real challenge in achieving the 3.5, the thin finish that we use on our 800 series, and I believe that will probably work its way into the rest of our line over time, but you know, baby steps, right? And there's an 800 series, as a matter of fact. The challenge in doing that was really in the hand phases of the process. And I think that points to a fundamental truth that any woodwork or wood finisher knows. The results are all about surface preparation, okay? So to kind of get back to your question, there's lots of great finishes you can put on a guitar. That's not going to make or break the quality. It's how you use it, you know, how you prepare surfaces, how you get it on there, you know, in a way so that you get a nice look without excessive buildup on the outside. So I hope that answers it. Yes, sir.
Is this considered a cleaner?
This is a clean room, absolutely. On the other side of this glass, the air is filtered, so any dust particles, actually people are required to wear a Tyvek suit if they're in that room. And then the spray cell itself has an even more controlled environment. The temperature and humidity inside the spray room have to be at a certain level. The paint is heated up before it comes out of the spray head. You can see that going on right now. Another advantage of this process is the finish is electrostatically charged. That really ties in with controlling how much finish goes on the guitar. If you spray by hand with an ordinary high pressure spray gun, most of what you spray bounces off the surface and goes into the air. So maybe you actually transfer 15 or 25% of what comes out of the gun actually stays on the guitar. So we'd have a really hard time controlling the amount of finish, to say nothing of how much we waste when we do that. The electrostatic component means the finish attracts to the guitar, and about 85% of it stays where we want it to stay. And so that gives us control over the buildup of the coat and eliminates a lot of waste. The UV cure means there's not a high level of what are called VOCs. That's the stuff that causes air pollution. Lacquer, by the way, traditional nitrocellulose lacquer, bad stuff for the environment. So maybe what you were referring to is that this shop has equipment that is acceptable because it traps all those VOCs before they get out into the air. But even if we could do that, we just don't like lacquer as a finish because it's hard, it's brittle, has bad fumes, it cracks over time, it turns yellow. I mean, maybe there's newer formulations that aren't so bad, but like I said, it was a generation ago that Bob Taylor, looked elsewhere for a finish solution.
What did they use for finish in 1996?
What did we use for finish in 1996? I was here then, but I wasn't in the finish department. I'm guessing at that time it was probably material called Fuller
Attention,
Glass.
please, if you are the owner of a
Not
Honda
lacquer.
Accord,
It was some other
please call line
intermediate step
200.
between when
Again, if
lacquers
you are
that are
an
old
owner
style
of
and
a
what we
Honda
use
Accord,
now.
please call line 200.
You're interested because you have a guitar from that day.
We have three.
Our customer service department would probably be able to tell you what finish was used on that guitar. Good question. Okay, let's move down this way so we can let Matthew get in with that part of guitars that's ready to start finishing. Give these people credit for having the skill in surface preparation to make sure that the finish is successful. And then the finish guitars and bodies on the way out of the finish department. Right here is one of the Tinker redwood top on it. Quite as dark black as that one that we saw. This must be a custom guitar. Tinker redwood top. Looks like it's got a bloodwood binding, this really bright red binding. Walnut back and sides. That's definitely not one of our standard models. Must be a custom guitar or built to order. These guitars are being inspected and checked out of the finish department and into the final assembly department. The first phase of final assembly is preparing the neck and the body to be connected to each other. And for that, we have to actually, cut this pocket right here. And this is done on a CNC machine around the corner, and it's a little tight to get the grouping, but it's the same pedal that we saw in the milling area. But it's got a special fixture, it's got special tools, and it's got a special operator who knows the ins and outs of the machines and the programming. So it's kind of like the finish, the machine doesn't automatically cut a perfect pocket for every neck so that when the neck is bolted to the body, it appears seamless when it's all done. It's not just the programming, but it's the operator measuring and setting calibration values for all of the tools and checking parts along the way. We have a window of like plus or minus 1/1000th of an inch tolerance when we're milling the pocket for the neck to fit. At this point, I should probably find out, are you all familiar with the new technology, neck system, we should really be calling it new because we've been doing it since 1999. It's a full bolt-on attachment, but the neck doesn't bolt to the surface of the body, it bolts into this hollowed out pocket, and between the neck and the body, we have a place to set in a spacer or a tapered shim. This one would fit between the heel and the body of the guitar. Okay? What I'm going to do is I'm going to hand these around. And you'll notice that one of them says -6, one of them says 0, and the other one says +6. We're not limited to those values. We have these in 0.02 of an inch increments from -24 to +24. So when they come around, if you feel the 0, it's the same thickness at either end. Okay, so let's start that one. If you feel the 6, it's 0.06 of an inch thicker at one end than the other. So that's going to rotate the neck in one direction. The -6 is also 0.06 thicker at one end, but it's the other end. Okay, so imagine having a whole selection of those where we can rotate the neck forward or backward in tiny increments. From one shim to the next isn't even a degree of rotation. It's a fraction of a degree of rotation. And what we're really after is at this point where we first connected the neck to the body, there's not even any strings in the equation. We just want to know, how does the plane of the frets line up with the top of the bridge? So know that our bridges are very precisely milled on a CNC machine also, so that they're always 310 thousandths of an inch. And we like that height, because when you get the bridge lifted that high off the top of the guitar, no higher or lower, and you get a saddle elevating a little bit above that, mechanically you've got a sweet spot in the tone production and the playability of the guitar. So long as the neck is aligned to it, in spite of all of the precise technology that was used to fabricate the body and the neck, every guitar is a slightly different, and the finish only needs to be a 1/2 mil thicker to require maybe a little bit different shim to go in that pocket. The finish on the surface is going to affect this body when it's loaded into the machine that cuts the pocket. So just that variation is enough to perhaps make this guitar require not a number 6 but a number 4 shim under the heel. So we determined that just by bolting the neck together. This is all done through the sound hole. 3 machine bolts through the sound hole, 2 of them into the underside of the heel, 1 of them into the extension of the neck right here. We get it all bolted up tight, and we make sure the neck is straight by adjusting the truss rod. And then we sight down the frets like aiming a gun, and if everything lines up perfectly with the top of the bridge, then we'll go ahead and fit the saddle, put the strings on. Actually, it really would already have tuners on it.
That's a custom.
Yeah, this is actually a neck and a body that weren't made to go with each other, but they were parts that were left over, so we kept it here just so I can talk to you all about neck angle. There was a phase in the early 2000s where we were doing a gallery series of guitars, and we did sea turtle inlays, and we had one with whales on it and one with koi fish. We brought back the koi blue color on 600 series color option, but we don't actually do the fish inlays on them anymore. So this is just the neck that was left over. Only by custom order.
What do those cost?
You have to work that out with our sales department. Right? They'll quote you a price if you tell them specifically what you like. Yes, sir.
Is there a difference in the truss rod between a 6-string and a 12-string?
There's no difference in the truss rod itself. There's a difference in the neck. The neck is a little wider.
Why?
And the profile, maybe just a shade thicker back here on a 12-string. But the truss rod itself is no different at all. It works by providing counter tension to the strings. So you may have to just tighten a 12-string truss rod a little more than you might on a 6-string because it's got to pull back more string tension. But that's all about maintaining the shape of the surface of the fretboard. So strings without a truss rod, the strings would just blow the neck forward into a severe forward curve, but tightening the truss rod bends it back the other way until this surface is level. Yes, sir.
There's a guitar over here. I just was curious what wood.
Okay, let me take a look. I'll aim this back up. Let's see what you're looking at.
There was one finished on the rack over there.
The second one, okay, that's Koa, but it's got a shaded edge first. Okay, we have a kind of a dark but translucent shaded material that you put on it. That's Koa backside. That is Koa backside and top. So is a transparent color. You can still see what your there's one that's black, all black. That's awesome. Thank you. That got really I like the metal. They're about the top of our line. The only guitar you would more weight. That would come in at a higher price point, and that would be the presentation. Top of the line and right below. Premium wood. Okay, let's continue this way. Thank you. To be sure they've got the right angle set before they move on to the string up and the final adjustments.
Is that the right handle for the box?
No, these actually don't go together. I can tell they're mismatched because the neck has a tortoise shell, not real tortoise, celluloid with tortoise grain like guitar picks. And the body has the solid black binding, so I know they weren't really made to go with each other.
So are they the right size?
Yeah. Oh, that's a good point. Actually, except for 12 strings, which need a little bit wider neck, also our nylon strings need a little bit wider neck. And some of our guitars have a narrower neck too, but other than that, standard neck, you could interchange any neck with any body. The pockets are the same size, the neck dimensions within 1/1000th of an inch are the same size. That doesn't mean we mix and match when we're in production, but it does make it possible that if a neck falls out of production for whatever reason, we can make a new neck and expect it to fit right on that body. If you have a guitar for service and the neck, the decision is made, it's better just to make a new neck, you still keep your original body, or vice versa.
There was a time when the neck was bound to the body,
right,
and there was no metal involved, and they were just glued, and the theology, I guess, was behind that, the resonance between the neck and the body.
Right, and I've heard that before, and what this gentleman is alluding to is there is prevalent thought in the guitar world that a glued neck joint is better than a mechanical neck joint because you have a more solid connection. But I would challenge that by saying if you actually took apart a dovetail joint, you'd see a lot of airspace between the dovetail and the pocket that it fits into. With the NT neck connection, there is actually more mating surface, more solid contact. And as far as the bolts drawing everything tight, they've got to be at least as tight as a glued joint. Now before the Taylor new technology neck, there was another way that we approached this. A disadvantage of a glued dovetail or any kind of glued joint is adjustability after the fact. And if you think that at some time in the life of that guitar you're not going to want to reset the neck, then you're in for a rude awakening at some point in time. But a solution that Bob Taylor came up with very early in the history of Taylor guitars was to glue only the fretboard to the top of the guitar. Okay, so the neck ended right here, and the base of the heel, where it was mounted flush to the side of the guitar, are two threaded inserts, and they can be bolted through the inside of the guitar, and the extension of the fretboard only glued down to the top. When guitars need a neck angle change, almost always you have to lean the neck back this way, right? It's extremely rare, unless the guitar went from one climate to a radically different climate, it's extremely rare you would ever deliberately need to adjust the neck up this way. So most neck resets are what we call raising the angle, which means lowering the action. And you can do that with our, what we call now our classic Taylor neck joint, by unbolting the neck, slipping a piece of sandpaper with the grit up this way between the heel and the body, and drag it back a few times. Probably like 3 times you've taken off maybe a 1/1000th of an inch of wood. Then you bolt the neck back, and now it leans back just enough to restore the action to where it needs to be. So, and we still have people in our repair department servicing those guitars to this day. The advantage of the NT neck is that the whole neck actually rotates when you change the shim. So it's not only the heel shim that changes, but this shim, there's another shim that goes under here. So the whole neck rotates. In order to do the classic Taylor neck joint, you really end up having to make the fretboard slope downhill a little bit from where it joins the body down toward the sound hole. Otherwise, as the neck pulled forward, in effect, the end of the fretboard would kick up like this, and then you have fret buzzing problems. So to solve that, to anticipate that, we tended to put a little bit of a drop off from the 14th fret to the sound hole and then that would allow those frets to stay out of the way while you were playing any frets back here. So that's getting maybe a little too technical, but it was a good intermediate solution that served us well for the first 20 years of this, maybe 25 years.
When was this one made?
I think the neck was probably made around 2004. There's no label to know when the body was made. And I think they were just parts that we had around, like I said, so we bolted them together and put them up here so that people that walk through our factory would be confused by it.
So that one's not for sale.
No, that's...
It's beautiful though.
I think we use it for skills testing. You know, before anybody gets hired at Taylor, part of the application process is to come in here and see if you can learn to see a neck angle. So we just take the bolts on and off of that guitar, you know, like once or twice every day, trying to see if somebody knows how to, can figure out how to set a neck angle. So that's what it's here for. Okay, let's keep going this way. Here we go.
We cut off.
Yeah, I put you on mute. We came from, with this building, it looked to me like we had all the space we would ever need. But I wasn't, like Bob was, anticipating that we would be making 162 guitars a day. So now, except for gluing in the peghead logo, and what Manuel is doing right now is he's got a jig that locks into two of those tuner holes, and he works the edges around a taper to cut it out to the Taylor profile. So that can work. But let's back up the story a little bit. You're going to see some parts of necks in different stages right here. Let's see. Yeah, let's just kind of come back here a little bit. I thought we had the department. We cut them apart and machine a little bit of an S-curve between the two parts and then clamp and glue them together. This is called a scarf joint. Car makers have used scarf joints for centuries. They just didn't do it with a CNC mill until the last century. So now we've got the basic flank of a neck except for the heel. The material for the heel, if I went through by number, I could find a heel that has the same number and it was cut from the same piece of wood. So that later when we add this back to the neck, like this. When we add that, when we add the heel back there, it'll be a good color match. You know, the glue joint is still apparent, but we want the wood to look like it all belongs together. We're not trying to hide the fact that there's more than one piece glued together. We just want to make it aesthetically pleasing. But the scarf joint gives us the peg head angle without wasted material and with actually extra strength. It's stronger than cutting it all out of one piece of wood, because otherwise the grain goes kind of the short way through that glue joint. The next step on this is 2 passes around the rotary shaper, and that gives us a neck length that's starting to take form from the face view, but we haven't really done anything to the thickness of it. The cutting off the peg head, scarf jointing it, gluing it back together, and then the edge profiling. The wood goes through some shock when we do that. So now we stop for 3 days and we actually store these necks in a wind tunnel, that allows them to settle down and move and switch. We've left extra thickness so we can come back and screw it up after it's stabilized after those 3 days. So the next step is this goes on the rotary shaper 2 more times, and now it's up on its edge, and that cuts off the back first and then the face of it.
So when you mean that it goes in the shop, the difference between how moist it is or how dry it is?
No, it's relieving internal tension in the wood. So what I mean by that is when this material is plain, level and flat and square, it's only level and flat and square because all the internal tensions in the wood are canceling each other out. And woodworkers would relate to this. If I took that 1-inch piece and stood it up on edge and sliced it into 2 half-inch pieces, they'll both twist, right? That's just the nature of wood, and we know that. So we always work the wood down to its final dimension gradually, incrementally in stages, and we let it stabilize, and we leave ourselves some material to trim it up as it relaxes each step along the way. Okay. So once we have done the on-edge milling, the next stop is at the truss rod station right here. And the truss rod install is all done on the second shift. So they're not going to fire that up until about 3:30 tonight. Here's the rod. If you go with me around here, we have really we would glue it in. Okay? So there's the rod. It's got to be as deep toward the back of the neck as we can get it. In fact, there's not much wood between the truss rod right back here. We get it buried in there deep. We glue a piece of wood over top of it called a filler stick. And then later, after we glued the fretboard on, if we tighten the truss rod, put a washer in the nut up here and tighten down on the nut. It tries to squeeze the neck shorter this way. And it can't really make the neck shorter, so what it does is it takes the path of least resistance, which is it bows the neck backwards. As we talked about in the string up room, that's ideal because we've got this other tension from the strings trying to bow it forward. So the truss rod, if it's installed correctly, gives us a smooth, even backward curve to counter the forward curve of the string. And once the truss rod is installed, then we do another truing up, a planing action on the back of the neck using a CNC machine, and another one on the face of the neck, and then we glue on the fretboard. And meanwhile, the fretboard has gone through an evolution from, or processing from a rough milled blank, although it's smooth on both surfaces. We use CNC programming to cut whatever inlay pockets go in that neck. This is done with a physical cutting tool that's about the size of a dental burr. Well, the tool is like a Dremel, but it's a CNC machine that's running it. It's not a person with a Dremel tool by hand. So the programming of the machine moves that little tiny bit in the pattern that cuts out pockets for whatever inlay goes in that fretboard. Then we glue the inlays in. Remember, these were lasered out. In the laser room, we put them down into the pockets. We fill the whole thing with epoxy. And when the epoxy is hard, we sand it level on the surface and cut the fret slots in it. So the fret slots are actually cut after the inlays, if the inlays go through the frets like this. And now that's ready to glue onto a fretboard, or onto a neck, I mean. And once it's glued on, then we'll cut and bind around it. We'll glue on a peg head veneer that already has binding in it, if that's the model we're going to make. And then we'll move on to the threading process. So this is really the core operation of the NT neck, is the threading. Let's go down here. Right now it's sanding the radius into the fretboard. Further than that, we can get another thread job right off the bat. For the most part, we do So back in on the right side of the machine table, where they're going to put the headstock out this way, and there's different tools like the final trim around the edge of the gas machine, the binding and the thread, the right length, there's a tool there that will bevel the thread. There's another tool that has the matches the three gas machine. And then, let me slide past you right here. Then Ray and Jody are both sharing this heel glue up thread between the two machines. So
Randy Fuller, please call line 200.
now
Randy
we can
Fuller,
move on the
please
heel.
call line
That's
200.
we wanted this out of the picture up until now because there's so many times we have to attach the neck to a fixture by the back surface and we just don't want the heel in the way. So now we'll find the heel with the matching serial number. We'll also do a visual check to make sure that heel is going to look good on that neck. And then go ahead and clamp it up. And from there they move on to a final carving. There's one machine. We're in luck because a lot of times by this time of the day, there's no carving going on. I carve 8 necks to perfect shape. Somebody was asking about neck profiles, and most of them use our standard 1 3/4 inch neck with normal tailored profile for the carving. But if you did a special order and you wanted a different profile of the neck, we have some other programs that we could offer for that. And we use an industrial version of tight bond wood glue, and it's plenty strong. There are occasionally heel separation issues. We also have a way to re-mill and glue a new heel and recarve if we need to on a neck that's already complete. But that's pretty seldom. Most of the time they stay on real securely. And we've had to do a lot of testing and development to know how to machine those parts so that we get a good glue joint, what kind of glue to use, how much pressure to put on it when we're clamping it. If it's over clamped, you squeeze the glue out and the heel will fall off. If it's under clamped, you get an ugly black glue line, and that's also a weakness point. So they use a torque wrench when they're clamping the heel on there, so it's just the right pressure. I think as I remember, it's 75 pounds per square inch. If it's more or less than that, torque wrench is okay. And then the final sanding is threaded here again to make the surface all look good without ruining the shape of the neck. Take some skill with the sanders, and they're working at benches that have a self-contained dust collection system. So as the wood comes off, it's just like immediately pulled down and filtered, so not too much here. Okay, let's keep going this way. Our inventory, so all the way over to the warehouse across the street. The warehouse is a smart building that knows where every guitar is on every shelf, just because it's reading all of the RFID tags of the, I don't know how many thousands of guitars we have stored over there. Come on all the way in so we can let that door swing closed. So this is the bracing department. Find a top that we can hand around. Actually, both of those, if you want to lift those up off of that rack right there and pass them around, they're ones that we just, sacrificed to be handled. Steel string guitars traditionally have some variation on X bracing, and we're not radically different. I do know some guitar makers have some really radical ideas about how the underside of the top. We go with tradition, but we tweak the tradition so that a Taylor guitar is voiced to sound like a Taylor guitar, partly by the exact geometry or engineering of the bracing on the inside.
Is that what makes the new 800?
Is that what makes the new 800?
Bracing or?
There are some little adjustments in the bracing. It's a number of things that make the new 800, and some of them are cosmetic and some of them are tone. I can't really speak to that in too much detail because you'd have to hear Andy Powers talk about that. And we got some videos up on our website about the new 800 series, so I'd rather you hear it from him than me, but definitely, some things are changed in the internal structure of the guitar to affect the voicing. But body shape is at least as important, if not more important, than internal bracing. The type of wood you use has an effect on the tone as well. So what happens in this room is we defined all of that by bracing templates like this. Those are back brace templates or top brace templates. So when we do a 6-string, each brace is going to be locked into the right place around the top. So they can't move. And the braces themselves are milled ahead of time. Let me see if I can find something over in these supply bins. The braces themselves were all machined before they got here so that they're already the right shape. Here, this is one of the back braces. See, that's already contoured, and that's just a matter really of gluing and locking everything into the right place and using vacuum presses to clamp everything down.
Are all the 12 strings baritone?
No, that's a template for a 12-string or a baritone. I think that is referring to the fact that there's an extra brace down here on the baritone guitar. There are 3 of these fan braces that you can compare with the other one. There's 2 down there, so that's another thing that affects the sound. Watch these guys down here because they're actually gluing on some braces. The bracing, the clamping of the bracing is done by sucking all the air out from under this lid, which has a sheet of rubber in it, and the rubber just comes down and wraps around everything. Here's some of the back bracing that was made out of a top that we didn't want to actually make a top out of, so we just sanded it down thin and we lasered it to make those reinforcements that go in between all of the back braces. And then when they're clamped together, we're going to put a bar over top to make sure that they get pressed down. This is the back of 800 Grand Concert. GA? DC. And those back braces are slanted, so that does affect the tone. And only on the 800 series, on the DCs and the GAs, we have those back braces angled a little bit. And again, Andy Powers would be the one to tell you how he knew to do that and why it's only on those 2 body shapes and not on the other body shapes. That's a little esoteric for me, I guess. And I will say overall, one of the things that Andy did is he just lightened up all of our braces a lot. You know, I think we may have been perhaps overbuilding our guitars to some extent. And he figured out how to change the shape of the braces so that they can all be a little bit lighter and really open up the voice of the guitars. So the brace tops and backs are prepared here, and then on the other part of the room is the side bending. So let's go over here. These are maple. Looks like a grand orchestra shape, I would guess. And there's a cutaway. All the shape around the edges is done by bending. And we start by bending a waist into both sides of the guitar at the same time. Let's see the next set for us. So he's got the 2 halves caged together, and there's little wooden cleats that lock them into the right place on the bender. That machine is dedicated just to doing the waist of a grand concert body. The waist on a dreadnought is different. The waist on a grand auditorium is different. So each one has its own dedicated bender. In about 1 minute, the machine will stop bending, and in another minute, the wood will have kind of cooked into that shape. So in 2 minutes time from when we started, the red button on the machine will light up, and you know to come over and press that and open it up and move it on to the back bender. So those ones are here just because you can't really bend the inside and the outside curve all the same way. And when the weight is bent, then it will slip right into here and we clamp it right to the machine and the bend on both ends towards the middle. So this is heated at 350 degrees. Just a little bit of water right where the waist. Some wood we have to do that. Other ones we do like rosewood, painted rosewood, and you don't have to put a drop of water on rosewood. But they're very thin too, right? So like 90 thousandths, less than a tenth of an inch thick. They're not really heavy. So in a total of 6 minutes, the sides get a complete shape without a cutaway. And then if it's a cutaway model, it goes through another bend on one of the seams on the other side of that half wall right there. And when all the bending is done, the sides go to the back of the room where we have a blocking station, and that's to glue in the solid blocks at either end of the sides, and that joins them all together. I like to think of bending and blocking the sides is like laying down the keel of a ship. Everything else, all the rest of the structure of the guitar in some way or another attaches to the sides, including the neck, which is bolted to the solid block that's on the inside of the guitar side. And then after blocking, the sides move to curving benches, which are along this wall right here. Let me grab a piece of kerfing and show you. So, a 90 thousandths of an inch is just not enough on the edge to glue the top and the back to. So we're going to line the rim of the guitar sides with strips of wood that are actually solid but slotted almost all the way through, so the whole thing becomes very flexible. We have a machine set up in Tecate. Use a table saw with a special jig to cut these strips so that they're triangular in cross section. And then we load them into a machine that has multiple saw blades. It's a gang saw, and it rakes through and stops a few thousandths of an inch from the back side so that that strip of wood is very flexible. And they match them for color so that when you look through the sound hole, it appears to be the same piece of kerfing going all the way around, but it's actually maybe 4 pieces that are just matched very carefully for color. And they glue and clamp those in, and when the edge of the sides is dressed up, ready to receive the top and the back, then the kerfing provides extra reinforcement for glue joints.
That's that. That stack there is how
Yes,
it ends
these are
up.
all kerfed and blocked, ready to go downstairs to the body assembly department. So this is an open call side 400 series with the Venetian or soft cutaway form. That turtle guitar we were looking at in the
Had a
string
hard
up room,
cutaway.
yeah, it has the it's called a Florentine with the sharp edge. We don't do many of those because it's a very takes a lot of skill. It's much more craftsmanship, I guess. In that. Anyway, to make the hard edge cutaway, you literally build the whole body and then cut a hole into it and curve the opening of the hole and bend another piece of wood and glue it in and then cut it out. We do those occasionally, but most of our cutaways are the Venetian style. I learned an interesting thing about Venetian cutaways and Florentine cutaways, and they really have nothing to do with Venice or Florence, but Gibson guitars back in the 1920s or 30s came up with those names because they thought they sounded old world, and it was a marketing thing. So if you ask somebody in Venice where their cutaway came from, they wouldn't know what you're talking about. Anyway, that's neither here nor there. Questions about side bending or bracing while we're here?
Some of them look like they go over, so then they cut it off.
Yeah, there's a little extra material on beyond the sides on the top and the back, and that's going to be dressed down when they get to the body assembly department, which is exactly where we're going right now.
Okay.
This gentleman is referring to a guitar, a model that he has, which has a tobacco sunburn shape on it. And where that fits into the finished scheme is that after we've gotten paste fill and a first coat of the UV, then we sand that out, and then by hand that tobacco shade gets sprayed. It has to be the right color, but you don't want to build it up too thick either. And then the final coat of clear UV goes over top of that so that we can rub out and buff without removing any of the color. And when we do that process here in El Cajon, and we do many other shades too, we have a special finish room right here where that happens. So it would be ideal if that were connected to the rest of the finish department, but right now the way we got these laid out, the guitars get finished up to that point, and then they travel over here to the shading room, and when that's done and cured, then they go back over there for the rest of the process. But it also kind of makes sense to have this room here too, because we also do the sealer. Some woods, particularly rosewoods and things in that category, just exude oily resin, and you'll never get finish to adhere to that if you don't provide some kind of chemical barrier. And that's what the sealer does. So the first step on those guitars is they get a wash coat of this special chemical that provides that it seals the oils in the wood. You put a light scratch on the surface of it, now you've got good adhesion for the paint spill and whatever goes on top of that. So we usually take the guitars as soon as they're final sanded, which is in that room right there, they go straight into that room for a sealer, and then they go to the rest of the finished department. So again, on this side is body assembly. Tops and backs are staged on guitars, sides are on these parts right here. I can slide this wrap over so you can see into the room better. And this actually is not going to give you such a representative picture because this close to the end of the first shift, ends at 3 o'clock. We're not really building any more bodies by now. They've moved on because we want to get them built and bound and straight and sanded and ready for finish all in the same day. And that means the actual body assembly has ended earlier in the day to work all those parts through the pipeline. But it's going to fire up all again at 3:30 when the second shift comes in. We just mostly split the workload down the middle. First shift makes 81 guitars, second shift makes 81 guitars, and an equal mix of models. But what Gregorio has right here is a guitar probably from the repair department that the top was damaged and needs a new top liner. We can do that without sacrificing the back and side. That guitar was already finished at some point. We have a way of cutting the old top off without damaging the side or the back structure, gluing the new top to it, and then proceeding with the trimming and the binding. But it's more or less the same process with a guitar that's built from the ground up. The sides get locked into that metal form. They get dressed by bowl sanding on the back edge because there's a 15-foot kind of dome to the back of the guitar, and you have a hollow bowl sander back in the corner that levels, the blocking and the curving, as you pointed out, we're sticking up above the sides a little bit. So that gets ground down level and maybe just kisses the side itself, but doesn't take a lot of material off. Then they go, the whole mold goes face up onto one of the CNC routers in the back enclosure there. And that does all the trimming on the top edge of the sides to get it ready to receive the top. Then we're going to dry fit. We always start by just holding the back against the sides and pressing it down with light finger pressure to make sure it's a good fit. Same thing on the top. And once that's done, the whole thing gets pressed up in here. We have a hollow plate to support the radius back. And we have a stiff metal plate that goes between this screw and the body, so the whole thing gets clamped up like a sandwich or like a big box, all in one moving operation. And then the bodies move into the bind and sand area. That's right down here. Now we're going to break out, there's about 11 people that are binding and sanding into guitars per shift. And what's more, by this time of the day, there isn't anybody that's, well, maybe there is. Okay, Derek over there is binding. The guy with the glue bottle at the workbench back there, like second from the wall. And the panel here, let me take this down and hand it around. We made this kind of sampler guitar that has a little bit of every binding combination, including that laminated abalone that we were talking about. So there's just a little bit of everything you might have depending on the model of the guitar. The first step is cutting the block with a router so that the leg in the side of the guitar are the right length. So whatever material
Could make us mind though.
Then the next step is gluing and taping down, and that's what Eric's doing right there. Wherever ends of binding meet together, we hand cut the liner so that there's a good tight joint right where that happens. And with the super glue that we use, you can hand that around to the group if you like. We use a slow jet, very thick weight super glue that doesn't drip all over the guitar, but it bonds very quickly. So 20 minutes after you tape the binding down, you can come back and remove the tape and move on to the straightening and sanding operation. Matthew's got a guitar there that's just been decayed. The binding is a little tall on the back and the top, so he used a router to get it close. And now he's using a hand scraper to shave the binding down right to where the wood is. And he'll do the same thing on the side of the car. The foam baffles hanging from the ceiling are sound absorption. So when the routers are fired up, they're pretty loud. So the foam just helps to absorb some of that, so it's not bouncing off the wall, creating a painful echo chamber for hearing safety. And then after the binding is scraped down, then the guitar goes to the stand-out room over there. It's surface prepared. You've got to have good surface on the wood, or else the finish is going to highlight defects. Right? So if you have a little scratch, it might be really hard to see unless you're highlighting the wood. When it's bare wood, it's really hard to see, but as soon as the first coat is finished, it's it. Now it sticks out like a sore thumb, and also you made it that much harder to carry if you finish before you fix it. So these guys are all really good about the surface sanding, surface preparation to make sure that you are ready to finish before they remodel. That's, I guess, pretty much the end of the story. We also want to see the sampler guitar.
Have you ever built a guitar where by the end of it they say, oops, not our,
That's a fair question. Unless there's actually a defect, there's no guitar that gets to, say, the string-up room that we just don't like it when it's put together. If there's a defect, everybody is vigilant from wood processing through final assembly. The sooner we catch a defect and stop production on that guitar or replace a part of it or whatever, the better off we are. But it's very seldom that a guitar actually gets completely made and has some flaw that's serious enough that we don't, want to release that guitar to the public. It does happen occasionally. I'm not privy to the numbers, how often the guitar has to be remade from scratch. Usually it's a remake, if at all, at some earlier stage in the process. Because we're looking out, like it wouldn't get all the way to finish, say to the string up room with a knot in the top, because somebody would have seen that before it even got into the laser room.
right?
And in which case they'd be sanding it down to make the back brace strips rather than making a top of it.
Here's a question on top of that. I remember a long time ago, Manny's New York, big guitar center, and I was buying a guitar that was a good guitar, and I said I need to see all 5 of that model,
Right.
and to be able to choose which one sounded better.
Exactly.
So that there is a possibility that out of the same model, there'd be one that sounds better than the other 5.
Okay, so let me kind of rephrase that for the rest of the group. We can build 5 guitars that are exactly the same model. Let's call it a 414 CE. And they're all oven call back and sides, citrus fruit top. They have the same binding, seam, decoration, inlays, same neck dimensions. You play those 5 guitars, all the same model, and they will all sound different. But that's not one better than another. That's just the natural differences in the material being allowed to present themselves once they're actually built into a guitar. But you should, as a customer, do exactly what you said. Play a bunch of them, or play different models. So, a 414 CE is going to sound different than an 814 CE because they're made of different materials. Indian rosewood in the back and sides will give a noticeably different tone than open call does in the back and sides. So in that case, it's not a matter of degree, it's just different personalities, if you will. So we always encourage our customers to find the guitar that fits you. We can't really tell you what's the right guitar. You've got to try. Don't settle for the first Taylor that you ever play. Play a bunch of them, right? And when you find one that, this is it.
Do you find that the Taylor guitar increases in sound and beauty as the years go on, like a Stradivarius?
All solid wood guitars sound better with playing because the wood relaxes from movement. It's not really the age, it's the playing. You know, it's working it in. You know,
I
voice of it.
heard somebody took a guitar and sat it in front of their loudspeaker.
Yeah, and I've heard that too. But I think you really have to have the strings driving the top to vibrate. It's also very important that you play your guitar in proper pitch too. If you're not paying attention and your E is not truly an E, you're not getting the best voice out of the guitar, and it's also not maturing properly if it's not at proper intensity when you're playing.
Back there where they're building the bodies,
Yep.
they're going to do a left-handed one. Do they just put it?
If we're going to do a left-handed one, we actually have to have a left-handed mold. The cutaway has to be put on the other side of the guitar. The bracing is reversed. The nut is the other way around because the fat string is on the different side of next. So there's many things. We have to know really all the way back in the laser room that it's left-handed.
From the start, it's left.
And then everybody in each department knows what to do to make that guitar
Do
left-handed.
they just turn around the other way?
Yeah, you can try that. And my experience is with most left-handed players, in order to just to survive in a right-handed world, right? Most left-handed people that I know are able to play a right-handed guitar. Whether you turn it around and have the thin strings on the top, or you just learn, like one of my best friends is left-handed. He plays baseball left-handed, but his guitars are all right-handed. And I really think it's how you start out. And if you learn to play with a right-handed guitar, or let me put it this way, everybody feels like you're left-handed when you first start to learn to play guitar. So I may be eliminating our market for left-handed guitars by saying that, but most people in my experience that are left-handed, if they start out playing right-handed, that's the way they learn and they're comfortable on the right-handed guitar. But that being said, we're always happy to make left-handed guitars and do that at no extra cost. Yes, sir.
Why doesn't Taylor put the built-in?
Put in what?
Built-in tuner.
The built-in tuner. I think it would offend our aesthetic sensibilities. It's one thing to have a pickup in there. I guess there might be some way to incorporate tuning circuitry into the pickup itself, but we wouldn't really want to add another component that's built into the guitar. And there's so many things on the market that you can flip onto the peg head or whatever, so we leave it to you to find the one that you prefer.
Are the employees cross-trained? Do they do the same job every day?
Our employees cross-train as much as possible because it allows us to handle the workload from day to day. The more cross-training there is. Not everybody is cross-trained in everything, but we have enough people that know how to do multiple jobs so that we can adapt if somebody calls in sick on any given day or somebody's out or whatever. We can move some people around and keep everything covered. Thank you. Okay, let's go this way. We're going to head out the back door.
I was wondering why. I was like, man, that sounds so good. It's $9,000.